Hi, I'm Ben, and this is the house I built out of shipping containers. Now, I've been interested in shipping container architecture for quite some time, but I had a really hard time finding good information about how to get building permits or how much would it cost. Well, we did the research, we documented everything that we did, and now we're so excited to share with you what we learned. So check it out.
This is episode 1, where we'll talk about buying containers, getting building permits, and pouring a concrete foundation. In the spring of 2018, I bought 10 acres of land in Joshua Tree, California. It's a square piece of land about 650 by 650 feet, and it has this nice little mountain right in the middle. While I was waiting for the surveyor to finish up the site drawings, I went ahead and ordered the shipping containers. Now, I had heard, like a lot of people have, that you can get shipping containers for really cheap. But in California, you have to use a one-trip condition container if you're turning it into a permitted house. This is just so that you can provide documentation for what's been inside the container, just to ensure that there hasn't been any radioactive or toxic stuff in there. I also didn't order typical containers. I ordered high cubes, which are a foot taller than a standard shipping container. This is going to give me more room for insulation, running wiring, and of course, because we're in California, sprinkler systems for fire suppression. Originally, I was only planning on using one 40-foot container to build one tiny house, but then I thought it would be really nice to have a guest bedroom and bathroom for visitors. And then when I checked in with my local building department, they informed me that there was a 700 square foot minimum for houses, which meant I would have to add a third container. So I figured a home office and workshop would be great. Now, even before I got the permit, I was allowed to move up to 50 cubic yards of soil. So I went ahead and started flattening out the piece where I wanted to place the house. I rented a bulldozer and hired an operator to flatten out this whole area, and it only took him 2 days. We then started digging for the monolithic slabs which are going to support the containers. Originally, we tried to do this with hand tools, but there was so much rock in the soil, it was really slow going. So we let the machine do the work, and then we just used hand tools to clean it up afterwards. Not only are there big chunks of rock mixed into the soil, there's whole veins of stone that go through it. We used 2x lumber to define the perimeter of the slab, and we drove stakes into the ground to hold these boards in place. Wood stakes kept breaking, so we switched to these steel stakes that already had holes in them for screws, and they worked really well. We had a whole bunch of 20-foot long pieces of rebar delivered to the site, and we began the reinforcement for the concrete. The structural engineer had specified the size of the rebar and the layout, so all we had to do was follow those drawings and wire it all together. I focused on cutting all the short vertical pieces, while the rest of the crew wired them all together. This isn't the most difficult work, but it does help to have a plan. The whole thing starts to get pretty heavy because you're basically creating one big steel cage of rebar all wired together. We spread out the 10mm moisture barrier and then shoveled clean sand on the top of that. I had always wondered how builders keep the rebar from just falling to the bottom of the formwork, and they use these things called dobies. They're just little concrete blocks with wires embedded in them, and they act as spacers. This was a lot of work in 100-degree weather, and it really made me appreciate all the stuff that goes on inside a monolithic piece of concrete. Originally, we planned on embedding all of the drain pipes for the plumbing into the concrete slab. But after laying out all the pieces and wrestling around trying to get them in the right position relative to the rebar, we just felt we weren't going to be accurate enough to line it up with exactly where the container would need to be, so we just switched it out for a simpler option and just made the final drain go through the slab. This just means we'll have to do the plumbing within the floor of the container itself. Now this is as far as we can go before having the building permits. We certainly can't pour any concrete until we get the final sign-off. California is a pretty regulation-intensive state, and here's the process we had to go through. The process starts with getting the site surveyed. In addition to measuring and marking out the topographical features, which is really useful for showing how the site will drain, the surveyor also researches the history of the site and defines all the boundaries and setbacks. Next up came the preliminary architectural design, where we laid out all the spaces and features. This design then goes to the structural engineer, who creates a set of structural details and performs calculations to prove that this building will meet all of the code requirements. The building department gave us the option of either having the architect or engineer stamp the drawings. We then compiled these designs into the construction documents and added in a whole series of reports and studies and forms that are all required by San Bernardino County. This is a complicated and expensive process because with each step you often have to go back to the previous one and have those drawings or documents updated. Alright, done with permits, time to have some fun, and it's concrete day. We have 3 separate slabs, and the smallest one is inaccessible for a truck to pull all the way up to, so we're going to have to pump the concrete. The crew got there a few hours ahead of the trucks just to make sure everything was good with the forms and to spray them down with water. The first truck pulled up to the pump and started releasing concrete into the hopper. It then gets pumped through the hose and delivered into the forms. There was always a few guys standing around with shovels to fill in the gaps of the form with dirt and rocks as the concrete levels rose. This was an exciting but a little bit stressful day because you have to order all the trucks in advance, and they kept coming about 15 minutes apart, so we had to make sure we were emptying one so that we'd be ready for the next one. The gray plastic pipes that are sticking up out of the forms are PVC conduit that will allow us to run electrical lines between the containers. Now the majority of these slabs are going to be covered by the containers, but we still had them smoothed out a bit. For the other slabs, the trucks could just back all the way up and the concrete could just come right down the chute. Altogether we used about 6 trucks and 45 yards of concrete. In addition to smoothing out the top surface, the guys also created some lines through the surface of the concrete. These are to create control joints which will allow for more expansion and contraction of the concrete without creating unwanted cracks. We also used some plywood boxes to create some openings in the slab, and this is just giving us a little bit more room to line up where the drain for the toilet goes. The last thing we did was to use an edging tool to do a little bit of a round over at the edges of each slab.
So the most common question I've gotten so far is, why did I choose to do a slab on grade foundation? And I get it. It seems like an awful lot of concrete for a container which is self-supporting. Well, a slab on grade isn't the first choice that I had. I originally wanted to do sort of a pier foundation, and I was very concerned with how I would level it since I don't have a lot of experience sort of setting these things. And so I was interested in doing some concrete piers with a steel beam that I could then level on site that I would weld the container to. So I sketched it out and sent it to the structural engineers. Well, they were initially worried about lateral support considering seismic activity. We're in California, we have to worry about earthquakes. And with seismic activity, you have to worry about the lateral load of the foundation, not just about how it takes weight straight down. So we then worked on a second version of this design where we connected the footings underneath the concrete columns so that it would create sort of a ring, and that would add enough strength and stability. But when I talked to the building department, they said that this would be classified as a crawl space, or at least that the area underneath the container would. And if that was the case, it would have to be at least 18 inches between the bottom of the container and the finished dirt. And the container floor itself is pretty thick, and so I didn't want to have my finished floor to be almost 2 to 2.5 feet off of the ground, because then if I do any decks or staircases out, I have to have all these railings which block the views. So at this point, considering both the challenges for what was originally a really simple foundation, adding in seismic support, and then in knowing that I'd have to raise the finished floor way off the ground, I scrapped this idea and started thinking about monolithic concrete foundations. Now at first I said, well, can I just do a perimeter beam that goes all the way around? It doesn't really need to have a concrete top, right? Like the container's only sitting on those edges. So the engineers worked it out, but that concrete ridge beam, because again, it doesn't have the lateral support from the actual top of the slab, would have to be pretty thick. So it ended up not being that much more concrete than just doing an entire slab. And when you actually look at how much concrete is per yard, it was like a cost difference of like $100 per slab. Now, that doesn't mean the slab is the best idea. I'm sure there's a lot of other foundation types that would have worked on, but with what we were working on here with this particular building department, and maybe just the limitations of our structural engineering firm, this is what seemed to make the most sense across the most bases, even though it didn't really seem perfect for any one thing. Now, my architecture firm's in Boston on the East Coast, and a lot of our work is out there. So we're used to doing basements or foundations that go well below the frost line. But out here in Southern California, that's less of a concern. So at least we had that going for us, which made the foundation a lot easier and relatively affordably priced. I know there's a lot of engineers, architects, and builders out there in the audience. So let me know in the comment section below what you think would work or would have worked better for this type of foundation. Also, any little tricks or tips that you might have for the rest of the audience about foundation design, formwork, what to consider when doing big concrete pours like that would also be appreciated. So I hope that clears it up why we ended up going with a slab on grade foundation. I know when you see houses like this, so many decisions seem arbitrary, and I'm looking at architecture all the time being like, wait, why did they do that? But before you sort of assume that somebody's dumb, although probably plenty of other reasons to do so, ask them why, because there's always these other considerations that we may not see just by looking at the photograph.
On the next episode of the Modern Home Project, we're going to rent a crane, move the containers, and start cutting out the holes for the windows and doors. Make sure you subscribe to this channel and turn on notifications so you don't miss an episode. We'll be posting additional information, including the architectural drawings, on our website. Thanks for watching, and follow us on Instagram if you want to see what we're working on next.